All right, here's a video on some angle practice worksheets. We did this one on a Wednesday in class, and then I'm also going to touch a little bit about these, a few examples here, and then I'm going to talk about this other worksheet which we haven't gotten yet. So if you see the video again and it starts off with this, be patient, you might kind of move towards the end, and I'm going to talk about finding the angles of each measure of each numbered angle. All right, so quickly, we're going to get through this. A lot of students were having some questions. It says identify each pair of angles as adjacent, vertical, or complementary or supplementary, right? Well, you have to think about what adjacent means, and if you need to write this down, write it down above it. What does the word adjacent mean? The word adjacent means next to, so I'm going to put next to, if I can here, hold on. You'll have room up there, I won't have room up there, next to. Okay, what does vertical mean? We talked about what vertical angles mean. If you forget, look back in your notes. All right, look back in your notes. But vertical means across from one another, and then complementary is equal to 90. Supplementary is equal to 180, and it's not letting me write that on there. So when you look at number one, just start with adjacent, then go to vertical, complementary, supplementary. Number one, can we say that these angles are adjacent? Are they next to? Yes, they're adjacent to each other. Can we say that they're vertical? Are they across from each other? No. Are they complementary? Do they look like they form a right angle? No. Do they look like they form a straight line? Some people are going to say yes, and I'm going to say no, because two angles have to be 180 degrees to be supplementary. How many angles do you see here? I see three. This is not form. Yes, the three together form a straight line, so the only thing I can say is they're adjacent. That's it. Done. I move on. Number two. Okay, what can I say about number two? Are they adjacent to each other? Are they next to each other? They don't look next to each other to me. They look vertical. Are they complementary? Do they add up to 90? No. Are they supplementary? Do they add up to 180? Ask yourself these questions as you go through, and you should be successful at that. If you get stuck on something, ask questions. All right, down here, again, look at your notes. I need to identify as alternate interior, alternate exterior, corresponding. We didn't talk a lot about alternate exterior or alternate same side exterior, which same side exterior is not even in there. We should know what a linear pair is. We should know what vertical angles are. You should know what these are. Well, based on this diagram, I'm going to look at angle 1 and angle 2. Angle 1 and angle 2. What does it look like they do? They're equal to 180 degrees. I don't see equal to 180 degrees up there. But does anything mean 180 degrees? Oh, gee, that's a linear pair. There you go. Now I move on to, and I'll just pick 14, 3 and 5. So I'm going to identify 3 and 5. What is the relationship between 3 and 5? Well, both of them are inside my parallel lines. Both of them are on the same side of a transversal. Same side interior angles. So for that one, what did we say it was, 3 and 5? SSIA, sorry. Same side interior angles. And I gotta go back, I'm erasing, I need to write. Same side interior angles. It's just, the process is that easy, all right? And you can sit there and you can go through, and my advice is instead of writing same side interior angles, actually write it out. Write out the entire sentence of what they are. Commit that to memory. If you just write SSIA, now you come back, what is SSIA? Well, now you gotta come back and you gotta look up here, it's a little bit more complicated. Right? That's the first worksheet. Now we're going to get to the second one. Angle practice part 2. Find the measure of each numbered angle. Well, based on what we did up here, what's the relationship between these two angles? Oh, gee, they equal 180. Exactly. Do I know what the measure of one of them is? Yes, and here's how you need to do this. Not how I'm suggesting, I'm telling you this is how you need to do that. It tells me 2 is 57, so I'm going to label 2 57. Now I know that both of these angles equal 180. So we saw in our work that we create the equation x plus 57 equals 180 degrees, and we solve. So minus 57 from both sides. X is equal, well, borrow from the 8, make that a 7. 10 minus 7 is 3. 7 minus 5 is 2. That should be 123 degrees. Right? I look on here. Now 123 degrees. Now the other suggestion I have is, what is the relationship between these two? The relationship between these two is that they are supplementary. And go ahead and mark 123 right here. and I'm just going to put supplementary. All right, further reinforces what we just talked about in the previous lesson here. Now move on to number, do we want to do number 2? Let's do number 4, all right? 2 and 4 are kind of the same, or should we do, you know what, I'm going to do 3. I'm going to do 3. You know that these are vertical. So the big thing with 3, the measure of angle 1, label your diagram. What do you know? They are equal. Well, actually, let's just do number 2. If they're vertical angles, they're equal. So if 1 is 38, 2 is 38, and y. Vertical angles are equal. Done. Right? There you go. You're welcome. Number 3. You're going to look at this and go, gee, it's all these angle relationships. Well, 5 plus 6 plus, it all equals 180. Yes, you're absolutely right. But stop and think. What should the sum of 5 and 6 be? Or what is the sum of 5 and 6? I know that 5 plus 6 is equal to 90 degrees, because this other angle over here is 90 degrees. So if I know that, and 5, which you should label right away because it's telling you 5 is 2, I know 5 is 2, then 22 plus 6, or x, whatever, let's not use 6, Let's use, if we're going to do anything, we use a variable, or we use angle 6 is equal to 90 degrees. That way I know that this is not a number, it's actually representing an angle. Well, I got to subtract 22 from both sides. So angle 6, now you know what it is. Again, you could use a variable. I could use x if you want, doesn't matter. My variable is equal to, make that an 8. 10 from 2 is 8. 8, 7, 6 is 68. Now, what is the relationship between 5 and 6? Because that's really what I did. Okay? 5 and 6 equal 90 degrees. Or I wouldn't even do that. I would say 5 and 6 are complementary. Again, further reinforce what we learned about complementary and supplementary angles. All right, one more I'm going to talk about. And that's down here on number 7. All right? And I think it's important to talk about number 7 because this gets a little bit more time consuming. You're probably not going to have to do all these. You're going to pick a few of them. What do you know about 13 plus 14? Well, gee, 13 plus 14 equal 180 degrees, right? So I'm going to go ahead, and this is how I did mine. I went ahead and labeled 13 as 4x plus 11. I labeled 14 as 3x plus 1. And I know that they both add up to equal 180. So 4x plus 11 plus 3x plus 1 equals 180. Yeah, this is a little bit more work involved, but it's nothing you can't do. Because you know that if you add them both together, they equal 180. So now we're going to combine like terms. 4x plus 3x is 7x. And watch how this squishes down really quick. 11 plus 1 is 12 equals 180. What do I do next? Well, you got to move the 12. So minus 12. Okay, when we minus 12, we get 7x is equal to 8 minus 1 is 7, because you got to borrow. 10 from 2 is 8. 7 minus 1 is 6, so that's 168. Oh my gosh. What do I do next? Well, this is telling you 7 times x is equal to 168. So you got to divide. Well, how many times will 7 go into 168? Gee, I'm not sure how many times 7 will go into 168, Mr. Wilson. Maybe you have to divide old school. 7 times 2 is 14. I'll do this down over here. 168. 14. 2, 8. How many times will 7 go into 28? 4 times. Oh my gosh, that was so hard. So x is equal to 24. Now, you're not done, because it says find the measure of each angle. So what do I have to do? Well, I have to take x and plug it back into each expression. This is easy. This is how easy this is. I'm going to say 4, and I'm going to show you this one, and my video's done here. Okay, 4 times 24 plus 11. What's 4 times 24? 4 times 4 is 16. It's going to end in a 6. And what did Mr. Wilson get? It's a 96. 96 plus 11. What is 96 plus 11? 96 plus 11 is 107. So this measure of this angle over here is going to be 107. And you probably can't see that, so I'm going to do this in purple. 107. Then I go back and I figured that one out, but you'll have more room on your paper. I did. I fit everything right in here. Now I got to say 3 times 24 plus 1. What's 3 times 24? 3 times 24 is 72, plus 1 is equal to 73. So this angle is 73. Now, what is 73 plus 107? Well, 7 plus 3 is 10, 7 plus 1 is 8. Gee, that's 180. What do you know? They are. So I have everything right here. I have my x equals 24. I have the measure of angle 13, and I have the measure of angle 14, and it's all right there. And if I show you my work right here, I'm gonna block these so you don't zoom in, but you can see all my work. It's all right there within the context of number 7. All right. There you go. There's a couple examples for you in the worksheets.